Hi, this is Randy Bias. I'm the CTO and co-founder of Cloud Scaling, and we're here to talk to Monty Taylor of HP.
I'm Monty Taylor. I work for Hewlett-Packard. I'm one of the founders of OpenStack and run the CI and infrastructure systems for the project.
Monty, tell us a little bit more about your role as sort of the owner of continuous integration for OpenStack.
So when we started the project, we knew we were going to be growing really fast. At least we knew that was a goal. And to facilitate that, we put in a whole bunch of developer automation systems so that the influx of developers could work on the project collaboratively and not mess each other up. Basically, when you have 700 developers like we do right now, each of them pushing hundreds and hundreds of patches daily, without testing, it would just quickly become a big pile of garbage. So what we do is we run an integrated code review system which is where all of the submissions go.
These are the gated commits?
These are the gated commits, right? Yeah, so they go in and they get tested a little bit first. When somebody first sends it up, we have 2 different clouds worth of machines donated from HP and Rackspace at the moment. Enovance is actually donating another one. We'll get some more over the next cycle. And we spin up machines and we install the code and we test it, report it back, and then the developers come and they do code review. It's enforced. You can't get code in without it going through code review. And then we actually, at that point, we test it again because the velocity is so great that in the time that it took somebody to review it, the code base has moved on. And so we have to double check that we can merge it in appropriately. And so again, we spin up 4, 5, 6, 7 full cloud servers, install OpenStack on them, run the tests against that, and only if that passes does the code actually land into the trunk.
So I heard you were doing this like as much as 700 times a day.
Easily, yeah. We actually merge 150 up to 150 patches a day. Wow. With all of that testing done. We don't merge. We don't merge somewhere more like around 7. So we get around 700 submissions a day that we test. Different versions of patches. Sometimes it's a really simple thing. Somebody will send something up. There will be a small error in it. Somebody will point it out. We'll test it again. But so yeah, we run a lot of tests.
So I remember in the early days, like in Diablo, right at the 11th hour, there was a regression that was introduced.
Yeah.
And I know that the code quality and the drops from Essex to Folsom and to Grizzly have just been increasing dramatically. And I attribute a lot of that to the continuous integration system and the infrastructure teams work in general. I mean, because it's a big 9-project coordinated release. Yeah. I mean, it's just going to get bigger.
It's only getting bigger.
So, you know, do you think about that the same way? Do you think you've had that same impact?
I think, well, so that's actually, it's interesting that you bring up Diablo, because that's the last release we did before we added automated integration tests. Before that, we were doing trunk gating, but the only thing we were testing on was unit tests inside of each project, which made it, I mean, that tests a certain amount of stuff, but there's only so far that goes.
Right.
Starting with Diablo, that's when we started actually spinning up completely pristine, brand new VMs inside of the cloud, installing a full installation of all of the pieces in OpenStack configured to work together inside of that, testing that, and then we delete it because at that point you've installed a cloud and inside of the server, and well, you God only knows what's happening with it. But so yeah, so that's when we Diablo, right after Diablo release is when we started doing that. And since then, the installation mechanism has gotten better, our automation around that has gotten better, and the testing that we're doing against that is getting more and more comprehensive. So as all of those things increase, it just allows us to hammer on this thing with a bigger and bigger hammer every time.
That's a huge amount of work, man.
It's not insignificant, you know. Yeah. Like we've got four core devs and a couple of other people who are sort of newer working full time on this. We've got like six to 7 people working full time just on this, and not on a test. This isn't like a QA team. Like I don't write tests to test Nova. I write the systems that run the tests to test Nova to make sure that it's done consistently, reliably, so that people can trust it because they have to, because their code doesn't go in if it doesn't work.
Well, you know, awesome. On behalf of my team, thanks, because it's made a huge difference for us.
My pleasure. I mean, look at how big this thing's grown.
Yeah. So last question I want to ask you is about the continuous integration infrastructure itself, because I think you're doing some very unique things there that people probably aren't aware of that are allowing you to get this level of scale and this level of automation.
Yeah, so we have it's essentially 3 pieces. We have a code review system called Garrett that was started by Google based off of a thing that Guido van Rossum had done called Rietveld. But they made this thing called Garrett, which is the code review system. They use it for Android Wikimedia actually also uses it. Actually, for what it's worth, Wikimedia uses the entire same setup that we use and work with us extensively on that, which is great. Garrett feeds into a system called Zool that we wrote. It's actually an OpenStack creation because Zool is the gatekeeper, if you've ever watched Ghostbusters.
Reference.
Yeah. So Zool is the thing that takes all the events that happen in a Garrett. Hey, somebody uploaded a change. Hey, somebody approved a change. And it understands what we want to do with gating. And very specifically, one of the features that it's got that just didn't exist before we wrote it is that we receive, like I said, 700 things. It takes about an hour to run a change. If we ran all those in series, it would take us days to process a day's worth of changes.
Right.
If we run them in parallel, then we actually don't know if we're landing the right thing because of the sequencing.
Right.
So what we do is we do parallel serialized operation, which is like optimistic pipelining from processors. So we actually stack things up, run them in parallel, but we know the sequencing, and we'll kick things out and rerun them if something does fail. So that was actually
pretty tricky, man.
it's some brain surgery. Like Jim Blair, who's on the infrastructure team, thought that. He called me one day. He's like, "Okay, I've got a crazy idea. Hear me out on this." And so he started working on it, and it's been like that's actually been without that
So
we'd be nowhere.
You map the dependencies, and then you can sequence
So as soon
it
as
while
somebody,
running in parallel.
yeah, it creates a virtual queue. Essentially, as soon as somebody approves a change, it goes into a virtual queue inside of Zool. The next change that's approved, we assume that the first change is going to merge. So we create another sort of change set that is the change that's currently being tested plus the new change, and so on. So, but we track that so that if the first change actually does fail, then we actually cancel the second job and then remake that with that change at the top of the queue. And so we build that up so we can do as many as we've got, but their sequencing is
literally
predictable.
like pipelining.
It's actually exactly like pipelining. Yeah. And then to actually run the tests, Zool fires off API calls to a Jenkins server, which is, lots of people use that for CI. We use it in sort of a drastically different way, and we're sort of pushing the boundaries of what Jenkins can do because of the way that we're using it. And so we've got a guy working on adding Gearman worker support to Jenkins, not so we can spin up things with Gearman on the backside to run jobs, but so that Jenkins itself becomes a Gearman worker, so we can actually have multiple Jenkins that can each pull a job off of the thing, because scalability-wise, turns out we have a lot of developers.
So you're running the actual infrastructure you do the tests on is a combination of HP's cloud and Rackspace's cloud. Is that right?
Yeah. So we run our development and build infrastructure as essentially a single application across two public clouds that are both running OpenStack.
So we're dogfooding.
We're totally dogfooding. We're talking about
awesome.
People talk about interoperability. They talk about whether we should have it. I mean, we've got it. It's never perfect. We're still growing as everything.
Baseline that
but we're doing it. We're actually
at least those two clouds.
At least those two clouds. And like I said, we've got a couple different of the other clouds that are spinning up OpenStack are going to give us things. So I hope by next summit I'll be able to say, yeah, we're actually running a single application across 5 clouds.
Nice.
And you would know it. Like it operates as one seamless thing.
All right.
Yeah.
Perfect.
Awesome.
All right. Thanks for joining us today. Thank you, Monty, for coming and giving us some information about the OpenStack CI system.
All right. Thanks, Randy.
Y'all know the name.